Hey everyone, welcome back to our sorting algorithm playlist. In today's video, we are going to break down insertion sort. Insertion sort is a comparison based algorithm that builds the final sorted array one item at a time. You can think of it like sorting playing cards in your hands, one card at a time, moving cards around until they are in the right place. First, we will go through a step-by-step visualization. I'll walk you through how insertion sort works on a sample array, illustrating each step, the element being inserted into the sorted part of the array, and the comparisons and swaps happening during the process. We will see how the first element is already sorted since it's a single element, then how the next element are compared and inserted into the current position one by one. At last, the shifting mechanism that ensures elements move to their correct spots. So, let's get started and let's see the working of insertion and insertion sort. Okay, now let's talk about first of all insertion, that how insertion take place. Okay, so as you can see, we have a sorted array, okay, 2, 6, 10, 15, 20, 25, and 30. So total 7 elements are there. And as you can see, they are already sorted. They are all in ascending order. Now we have to insert 12 in it. Okay. And we have to insert 12 at such position that the array should remain sorted only. Means it should maintain it in ascending order. So we can clearly say that 2, 6, 10, and 15. So between 10 and 12, 12 should be placed. So its correct position is after 10. Okay. But when we are going to insert it, so what we are going to do, first of all, we'll create one more room. So in total, first of all, there was 7 elements. We'll create one more room. Now, then we'll start comparing this 12 with the end, okay, with the last element. So 30 is the last element. So we'll start comparison of 12 and 30. So obviously 30 is greater. So when 30 is greater than 12, we will shift the 30 to rightwards. Okay, suppose here a room has been created at this place to my arrow. Okay, suppose a room has been created for 12. Now 12 will be compared with 30. Okay, then 30 is greater, so 12 will be moved rightwards. Then 25 is also greater, it will also move rightwards. 20 is also moving rightwards. 15 is also moving rightwards. Then when 12 is compared with 10, 10 is less than 12. Now this is the time where we will say that at the empty place where earlier 15 was, but now 15 has been shifted, so there is an empty room. Now in that empty room, we are going to place our 12 there. Okay, so elements which are greater than 12 will be shifted right. Okay, will be shifted rightwards. Now let's talk about the time taken here for only inserting. Okay, for only inserting the element, what was the time which we took here? Okay, so suppose if it was 12, so how many time? 1, 2, 3, 4. Okay, so after 4. Okay, but what if it was 1? So total comparisons will be made n numbers. So what will be the maximum time taken? Okay, because we consider time not on the average basis, we consider time on the maximum and minimum basis. So maximum time will be what? Maximum time will be when it was the smallest element. So instead of 12, if it was 1, so it will be compared with all the elements and then 1 will be put at the first place. So it means n comparisons were made, and so the time complexity for the insertion was n. So maximum is on the degree of n when all the elements are shifted. Okay, now suppose if it is 32. So if it was 32, so it will be right, it will be placed just at that first place, at the last place only. If we'll start comparison from the end, so it will be put somewhere here. So it will take a constant time, degree of 1. So that is considered as when no shifting take place, so it will be considered as a constant time. So this was all about insertion. Okay, now I hope you have understood how the element is going to be inserted. Now we will see a step-by-step execution and the comparisons and swaps, okay, in insertion sort. Now, for example, I have taken an array 85732. Okay. Now, when we talk about insertion sort, the first thing is that the first element we consider to be sorted. Okay, so we assume that first element is already sorted. So here 8 is the first element and we are considering that 8 is already sorted. So we'll start, okay, using passes. Okay, so we'll start by first pass. So first pass, in first pass we are going to insert the just next element, which is 5. Okay, now 8 is already, we are considering 8 is already sorted, and then we are inserting 5 in it. Okay, forget about 732. Okay, now just think that 8 is already present in an array and 5 we want to put it. Okay, now when we are inserting 5, so 5 will be compared with 8. As 5 is less than 8, so 8 will be shift towards right. Okay, so when 8 will be shift towards right, so 5 will be inserted at 8 position. Okay, so our resultant array will look like this: 5 8 and then 7 3 2. Okay, so how many total comparisons we made? Only one comparison. 5 is compared with 8 only, and because 8 was greater, so swap is also made. The maximum swap was 1 only. Okay, then let's come to the second pass, in which we are going to insert 7. Okay, now forget about 3 2 now, only 7. Just look, only 7. Now, so for 7, the comparison will be made 2 times with 8 and 5. So let's do that. So we are comparing 7 with 8. 7 is less than 8, so 8 will shift toward rights. Okay, then 7 will be compared with 5. 7 is greater than 5, so what we are going to do, we are going to insert 7 after 5. Okay, so our resultant array will somehow look like this: 5 7 8, then 3, and then 2. Okay, so how many comparisons we have performed? So total comparisons we performed here is 2. As you can see, 7 has been compared with 8 and 5, so 2 comparisons. How many swaps? So actual swap was 1. Okay, because 7 is not greater with 5, so that swap is not made. So but I have always told you in the criteria analysis video that we are going to consider the maximum swaps. So maximum swap was 2. If instead of 5, if it was some greater element, so the swap will be made. So we are going to consider the maximum number of swap, not the actual swap. But for, okay, but for there should be no confusion, I have written the actual swap also. Now let's come to the third pass. In the third pass, we are going to insert 3, because 3 was the next element. So 3. So we are going to compare 3 with 8. 8 will shift towards right because 8 is greater. Same, 7 is also greater and 5 is also greater. So all the elements now they will be shifted towards right, and 3 will be placed at the first place. So now this will be the resultant array: 3 5 7 8 and 2 till third pass. Total comparison 3 and total swaps are also 3 here. Okay, now fourth pass, this is the last pass. Okay, in this, and you will notice when we are coming toward the last pass, you will have only one element left. Okay, so in the fourth pass we have only left with 2, only left with the last element, which is 2. Now again, comparison will be made with all the elements. All the elements are greater 8 7 5 3, so shift they, all the elements will be shift towards right. So 2 will be inserted at the beginning. Resultant array will be 2 3 5 7 8, and your array is now sorted because no element is left and you are at the last pass also. Total comparison made is 4 and total swaps made is also 4. Now, how we can consider that this is the last pass? Okay, that is based on total number of elements. Okay, if total number of elements were 5, so total pass is going to be 4 only. So it is n minus 1. So if we'll go to the total analysis of all the passes, means all the operations which we have performed, all the comparisons and swaps. So if we'll do the total analysis of them, so you can see that total number of passes will be in the form of n minus 1. So if there is 5 elements, so 4 passes. If there is 6 elements, 5 passes. If there is 4 elements, 3 passes is going to be made. So now what is the total number of comparisons is going to be made? So total number of comparisons that will be taken is, as you can see, in the first pass 1 comparison, second pass 2, third pass 3 comparison, fourth pass 4 comparison. It is in the consecutive sum. Okay, so 1 plus 2 plus 3, and this will be going to n minus 1. So if you have 5 elements, so the consecutive sum of numbers will be till n minus 1 only. So for 5 it will go through 4, means 1 plus 2 plus 3 plus 4. If it is 6, 1 plus 2 plus 3 plus 4 plus 5. Okay, now so for consecutive sum, the polynomial will be formed as n into n minus 1 by 2. So if we'll solve that, so we'll get the highest degree, which is degree of n square, degree of n square. Now same goes with the total swabs, because as we are considering the maximum number of swabs, so they will be also in the sum of consecutive numbers. Okay, so till n minus 1, so they will be also in degree of n square. Okay, now let's come to the insertion sort algorithm. Let's talk about the algo, how we are going to write the algo for insertion sort. So first of all, we'll create a function. This function is going to take two parameters. One, it's going to take the array, and then the number of elements in that array. Now the main part will start from the loop. As you can see, the loop we are starting int I equal to 1, I less than n, and I plus plus. So I less than n means n minus 1, till it will go till n minus 1 only. Now I equal to 1, why we are starting with 1? Because I have already told you that we are assuming that the first element is already sorted. So first element is present at the 0th index. So we want to start from the first index. Okay, so that's why it is starting from 1. Then we are taking one more variable j, and we are assigning I minus 1 to it. Now why we are assigning I minus 1 to it? Because the comparison which we are going to make, as you can see here, suppose this is the array, and at the first pass 5 is going to be inserted. Now the comparison of 5 will be done with 8. So 8 is at which place? 0th place. So why we are doing I minus 1? Because we are starting the loop from I equal to 1, means from 5. Because at a of I, means at array of I, that is the I value is 1. So at a of 1, 5 is there. And we want to compare 5 with 8. 8 is at 0. So j equal to I minus 1 will be, I is already 1 and we are doing minus 1. So plus 1 minus 1, it will be 0. So 0 in j, there will be 0. So I will be compared with j, means 5 will be compared with 8. So that's why we are doing here in j equal to I minus 1. Okay. Now this is the very important part. That's why I want to make you understand this. Okay. So suppose if I is equal to 2. So if I equal to 2, so comparison will be made with 5 and 8, or means the sorted one. 5 and 8. So how will be made? 7 means I equal to 2. So j equal to I minus 1. So what will happen? I is 2 minus 1. So it will be compared with 8. Okay. One previous value. With one previous value. That's why minus 1 is there. Okay. Now I hope you have understood. Now, then the current element. We have to store the current element also, because shifting is made when if it is greater, a shifting will be made. So we need to remember the current position also. So that's why we are storing a of I in x. So this x is denoting the current item. Okay. Then we are taking one more loop. Okay, that is the nested loop, and this time we are using a while loop, because we have to shift, and we have to shift till this condition doesn't get false. So we have to shift till that. So what is the condition? First of all, j should be greater than minus 1. Yeah, because j is still 0 only. If it is getting minus 1, it means what? We have to stop there. Okay. So first condition is that. Then the second condition is if a of j is greater than x. So we will execute till only when a of j is greater than x, means it is greater than the, if it is greater than the current item. Okay. If a of j is greater than the current item, which is x here, so swap will be made. Swap means we are going to shift the current item towards the left and the greater item towards the right. So because of that, we have written here a of j plus 1 equals to a of j. Okay. So whatever the current item is a of j will be placed in a of j plus 1 in the greater value towards right. Okay. And to go to the previous value, because we have to make the comparison with the previous left ones also. That's why we are decrementing the j minus minus. Now this will be done, and when this is completed, when these conditions get false, so we will come out of the loop. After coming out of this while loop, what we are going to do in the next value, suppose in this example, when 12 was compared with 10, so 10 is less than 12. So at the place of 15, so j minus minus is suppose here, so that's why we are using j plus 1. J plus 1 means that j minus minus is 10, we are comparing with 10. 10 is less, so with one greater value of j, store at that place. So suppose j is 0 1 2, so at third place store it. Okay, third place keep it. So because of that, we have written here a of j plus 1, and we are putting the current item there. So this is the algorithm. Okay, now in the algorithm also you can see here we have considered total number of comparison is in the degree of n square, and here also with the algorithm also it is clearly mentioned that, as you can see, we are using two nested loops. Okay, so basically we are doing two times. One is the for loop, and then we are using one more loop, which is the while loop. So that's why it is degree of n square. Okay, so with algorithm also it is clear. Now let's come to the next thing. There are some special characteristics of insertion sort, that is it is adaptive and it is stable. Now let's see how it is adaptive and how it is stable. So adaptive, because if the array is already in sorted format, or you can say if it is already in ascending format, so at that time we don't need to perform any uh, comparison. So what will be happen, time complexity will be n, because only the comparisons will be made one time only. Okay, so the time complexity become degree of n. Okay, and what is adaptive? Adaptive means that if it is taking less time, if it is taking a minimum time and maximum time, so it becomes adaptive. So yeah, it is adaptive. And the worst case is that if it is in descending order, so when it is in descending order, then the time complexity of is degree of n square, that we have already seen. So yeah, and one more thing with insertion sort is that it is by nature it is adaptive, because we are not taking any, in the algorithm also we are not taking any extra flag to make it adaptive. Okay, it is by nature adaptive. So behavior of insertion sort is adaptive. Now stable, we'll talk about a stable. First of all, yes, it is a stable, but we'll talk about a stable in the at the last. Okay, at the last we'll talk about the stable. So now let's go to the code and write the code, and let's see the execution of insertion sort. So in the code, what we have to do, we will first create a function. So I have used the previous code. So I have already created n, and I have taken an array. Okay, and I'm calculated the size of the elements. Okay, now what I'm going to do, I'll create an function which is going to take array as a parameter and the length, size of the elements. Then we'll start the loop. Okay, let's do what? Let's take I and j here. J equals to, what do we have to do? I minus 1. Okay, and x equal to a of I. Okay, the current element. Now after that, what we have to do, now we'll start the while loop. Okay, and in this while loop, the condition will be, there will be two conditions. First we'll check that j should be always greater than minus 1, and a of j should be always greater than x. If these two conditions are if these two conditions are true, then only we are going to shift. So a of j plus 1, in that we are going to fit a of j, and each time decrementation of j is also necessary because we have to compare with the previous element again and again. Okay, so that's why a j decrementation is necessary. Then if that condition becomes false, so in a of j plus 1 we are going to put our x. Okay, so this is the code. Now I've already taken the array, okay, arr1. So I'll do what? I'll call the function with arr1 and n in it. Now all set. Now let's run the code. Okay, so now you can see the array was 87654 and it is sorted 45678. So this is the code, okay, which is how you're going to use it. Okay, let's go back here and I'll show you a simple visualizer using what? Using this, you will easily understand that how it is working. Okay, so I have prepared it for you guys to understand. So how you can see 74 is being compared with 72, then 74 is being compared with this, the previous element, then 16 is compared with 74, then 72, and then 53 and 16 will come here. Okay, then 56 is compared with this 74, 72, and then 53, 56, and then 53 will be placed here, then again this, and now your array has been sorted. So total number of comparison made is 14 and swap made is 8. Okay, again I'll show you with a new array. So this is the array 96, 26, 71, 30, 28, 51 and 14. Okay, now it will start from 26. Okay, so 26 will be compared with 96. Let's see that. Okay, starting with 26, comparison is made with 96. 26 comes to 96 here, then 71 is compared with the previous element, and then again, okay, this will happen. Then 28 is being compared with 96, then compared with 71, then compared with 30, then 28 is placed before 30. Okay, then again, now let's see for 14. Yeah, 14 is now start comparing 96, so right shift 96, 71 right shifted, 51 right shifted, 30 right shifted, 20 right shifted, 26 will also be right shifted, and 14 will be placed at the first place. Now your arrays is sorted. So total number of comparison needed here is 21 and swaps total made is 15. Okay, so it starts from this very basic first place elements, means the second element. I'm not talking about the index. It will start from the second element because first element we are considering as already sorted. Now this will be compared, means with this. If it is greater, right shift will be made and this will come here. Okay, then this will start next item. Okay, because we are starting from here, so after this is completed, this will be started. This will be compared with this element. If it is greater, shift. Okay, and this will come here. Okay, then this will be compared with this. If it is greater, then shift, then it will be here. Okay, then again the next element, and so on. It will be done for all the elements. So that's why it will consider the maximum number of time when it is in descending order. So if it is all in descending order, so maximum number will be taken, so degree of n square. Now let's talk about how it is stable. See, if there is 14, okay, and now if you want to insert 14 again, okay, so what will happen? 14 will be compared with 96, okay, 71, 51, 30, 28, 26, again 14. When it will be compared with 14, what will is going to happen? This is not greater, means 14 is not greater than 14. They are equal. But we are checking, as you will go in the code, you will see here I have written greater than, not equal to. So if it is equal to, then also the condition is false. So shift will be not made. So when the shift will be not made, so that particular thing, means that position will be made earlier. So the first 14 will be at the first place only and the second 14 will be at the second place only. They are not going to interchange because we have not used the equal sign here. So yeah, so we can say that it is stable because it maintaining its relative order of equal elements. Okay, so if they are equal elements present in an array also, so the relative position, the initial position of those two elements will be maintained. Okay, so that is there. So I hope you have understood insertion short. Okay, so thanks for watching the video. Stay tuned up. We'll see you in the next video.